Hello everyone. Here we have a Realtor application designed for a real estate company. It houses a database where the company is going to store information that is important to them. Now, within this database, it is going to answer about 10 different questions using 10 different queries. So, for example, the first question, we want to be able to understand, we want to find who are the customers that qualify for a mortgage and a property. Um, as the database houses information on customers and its properties, we look here at the query that is going to be used to find who are the customers and what is the mortgage that they qualify for and the query and sorry, the property. Now, this aspect of the query, the order by clause, allows you to sort the information in a really systematic way. Let's say as the database begins to grow in size, you will want to present your findings in a really structured kind of way, whether it's in alphabetical order or so forth. So when we run this query, you can see a list of the customers on the system, and it has been sorted in this case um, by surname, right? So this is how the order by clause works. Let's go on to the second query. The second question, as a matter of fact, here we want to be able to know who are all the real estate agents and the brokers in which they are assigned to. So the query that has been used to get this data here, right? You can see it's a select query. We are looking at the agent table, and we are going to join that with the broker table. So we are going to perform an inner join on two tables to get this information, right? Who are the agents and the brokers that they are assigned to. So when this query is executed, you can find a list of all the agents, the names of the agents, as well as the broker, the name of the broker, which is the company that they work for, right? They are assigned to. So this is how you use the inner join query, the inner join clause. Next, we will move on. Another question that we want to be able to answer is, which are the highly priced properties and in which city are they located? So in looking at that query that can be used to get that information, we can use a sub-query in a where clause. So this is what the query looks like, right? This aspect of it here is the inner query, all right? And then you have the outer query, okay? So we want to be able to determine which areas the company considers affluent. So, for example, uh, a highly priced area could be one in which a highly priced property, sorry, could be one in which the average price of a property is more than 100. The average price of a property has the average price of a property plus $100,000 more. It could be considered a highly priced property. So within the query that we used, right, the subquery and the outer query, we were able to get that information. Right? So this is a list of the highly priced properties as well as the city in which they are located. Another question that we can answer, question 4, it relates to what are the income ranges of properties that customers show interest in, right? So, every property has a particular income bracket in which it qualifies for. So if we want to know what are the income ranges of properties that customers show interest in, we take a look at the query. And let's say we want to use partial matching in the where clause, a query that uses partial matching in the where clause. So partial matching would include things like, that is this area here. And let's say we know that customers are usually interested in properties that start with ST, right? You want to be able to pull a list. It could be any particular city that starts with ST. So this is the aspect of the partial matching clause, and this is what our query look like, right? And once we run that query, we can see a list of cities that start with ST, which is pretty much like what the customer prefers, and the income ranges that are assigned to those cities, meaning the income range that can allow you to qualify for properties within the cities that customers prefer. Moving on, we are going to look at some aggregate functions. So question 5, we ask the question, what is the value of properties sold, leased, available, etc., and the total number of cities they are spread across. So looking at the query, we are using here an aggregate function on the city field as well as an aggregate function on the as price field. So again, the question, what is the value of properties sold, leased, available, and the total number of cities they are spread across? All right, so we have that query and we group it by status. When the database is executed, when the query is run actually, you get a list of the different property status, so you can see which property there is a property that is leased, the value of the property is $5,000. It's spread across just one city, whereas we have properties that are available, and this is the value of the total value, the sum value of the properties that are available, and it's spread across 10 cities. Now, this is useful because you want to be able to have at a glance all the properties that are on your database. They carry a value, and it can help for revenue related purposes where the real estate broker can understand what type of revenue he has coming in. So for properties that have been sold, it can help him to understand, okay, so I should have at least about $445,000 in revenue based on the properties that have been sold by us. So it allows you to make that kind of analysis. Moving on, we also want to be able, this is question 6. So we want to also be able to understand which agent has the highest clientele. Now we want to see what is the performance rate of these agents, how many clients they are bringing in, how many customers they are bringing in. So to do that, to find that information, we have used a group by, a query using a group by and having clause. All right, so this is the query here. Okay, this is the group by section here and the having section. So this is our inner query, right? So inner subquery as a matter of fact, right? And our outer query. And this is what has been used to get the information on how to understand how the agents are performing. So when it's run, we can see that we have one agent here that has performed the highest. This query can also be modified right? To add like an aggregate function, to count how many of the properties that she um, the amount of, sorry, not the amount of properties, but the amount of customers that she has brought in. But basically, this is a query that uses the group by and having clause. Number seven, moving on. Okay. So for this query, for this question seven, we want to get a list, we want to get the average income of the customers on our database. So this is the query that we're going to use to get that information. This one uses select a subquery as a relation. So this is what is used to get the average among the average income of customers on a database, and it's useful to understand things like how much the customer could qualify for. You could also make other analysis like, what if the customer's income increases by 10%? It could afford them a different type of property, maybe a more expensive property, maybe they can save on a property. So understanding what the customer is qualified, what the customer's average income is on your database can help you make some kind of analysis or do some kind of marketing or so forth. Right? At the same time, you want to be able to know that the customers have there's a very fair average amount that would allow the customers to qualify for a property. Next question. Question 8. We want to know sometimes which agents work together. So sometimes agents, although an agent may be assigned to work on a property, agents usually co-broke, enter into a co-broken relationship where they try to sell the property or lease the property faster. So they work together in effort to try to do that. Um, to pull that information from the database, here we use a self-join clause, right? A self-join query. And in this case, we are just using one table and we're gonna, use that table, join it onto itself basically. So this is the Cobrook table that we are joining onto itself. And when the query is executed, we can see, okay, well, agent ID 1 works with agent ID 3, agent ID 2 works with 5, 4 works with 10, and 6 works with 9. So these are the agent IDs and who they work with. And it's just useful if we need to get an understanding of who has been working with each other. Moving on, we'll go to question 9. And here we ask the question, well, what are the properties and its owners and any legal documents, for example, a deed? Now, to get that information, we've actually used a view. So in this case, we will go to take a look at what the view is like and what the query is like, right? So we have a couple of views here created, and we would look at the property, right? And this is, we'll take a look at the data as well as the code. So this is the data here that has been pulled. It's a list of all the properties. You can see the property ID, asking price, the house, lot, street, city, country, the customer type that identifies that it's a owner. This part is especially useful because there should not really be a prospect in here. The property, the persons who own the property should be listed as owners. So this is a very useful view to identify errors like that. Um, the owner's first name, their last name, and here we have the legal documents, right, which is the deed to validate that the property has some kind of ownership. We can also see the agent who would have registered this type of customer and the broker in which he belongs. So at a glance, you can see a lot of information here. All of this data is actually split into numerous tables. So if we go to SQL, we can see what the query is like. Okay. So you're going to pay attention to here, this aspect of it here. 7 different tables used to get this information. And as we said, at a glance, you can see a lot of things instead of going from different table to table. At a glance, it shows you a wealth of information about the property, the owner, and legal documentation. So this is a very useful view, and it can be used further in other queries. Okay, so we have here just some other views we can take a quick look at. This one shows you a list of uh, customers, prospects, and their income ranges and the properties that they can qualify for based on their income range. Another useful view, and yes, also um, it is pulling uh, different tables. You can see here, 6 different tables it's pulling from. And we can also take a look at this other view here, customer, right? And it's just pulling from 2 tables, but this data allows you to see a list of all the customers and it's the customer type. So in this type of view, you can see well whether the customer is a prospect or an owner, right? So that's it for views. Um, let's go to question 10. So we'll go back to the app. And in this case, we want to understand how many agents are assigned to brokers. So to get this information, we have decided to use, instead of a table, use a view. All right, so you can see here, this is the query, and we've decided to use a view in this case to understand how many agents are assigned to brokers, and it uses aggregate functions as well. As you can see here, we're going to count the agent ID, right? And when this is executed, you can see the different brokerage firms on our system and the number of agents that are assigned to them. So here we can tell, at the company could tell at a glance which other brokerage firm that they have been working with, also whether they need to increase the capacity or reduce capacity. So for human resource related reasons, this aspect of information is important. Also for co-broking and sharing reasons, they can see who are the other companies, the other brokerage firms that they network with. Right, so these are 10 questions using queries, and we're also going to take a look at the trigger. Now, to look at the trigger, we will go to the command prompt, and we are going to try to, we're going to enter we're going to try to insert some data into one of the tables, into a property list table. Let's just take a look at what the property list table has first. All right, so we're looking at a particular agent that we know would have listed at least 5 properties. So this trigger, to explain this trigger, um, there's a business rule that says an agent cannot list more than 5 properties. So we can see here on the property list that this agent, agent ID 1, has 1, 2, 3, 4, 5 properties listed. What we're going to do is try to insert another record and see if we're successful. So let's get, let's just get, okay. So we found the query, and we know that, again, we know that the customer, the agent already has already reached this amount, and we are going to try to insert another record for this agent, agent ID 1, right? Let's run this query. And here we can see the error. Sorry, you have reached your maximum limit of 5 properties. So this shows that our trigger works, and we can also go and see where our trigger is. Let's go to the object browser and take a look at our trigger. So here's our trigger, maximum property list. So this is our trigger. All right, so here it is where we've declared the counts, and here it's going onto the property list. It's on the property list table, and we're looking for when a new agent is entered. In this case, we used agent ID 1, and this is the error message that we saw that was generated, right? If the agent did not reach its count, then it would have been saved successfully, right? So this is our trigger. We showed that it worked. We have shown 10 different queries, some questions that we can answer, as well as we looked at views and the trigger. Thank you all for watching.